I'm just kidding. Oh my God, I've always wanted to do that. Do you guys listen to ASMR? They've got some cool ideas over there. I feel like I have a soothing voice. I could be like an ASM artist or something. That'd be a good time. Anyways, welcome to this week's lesson, everyone. I hope we're all surviving required learning and all that kind of stuff. And I hope you enjoyed the less ugly video with stuff on the top and the bottom. I'm excited to continue that this week. Um, we are just going to move right into chapter 8 for this week, moving on to 8.3. And I'm going to tell you now that this lesson this week is a lot less work than last week. We're just kind of taking it back. The sequencing in our book is just weird sometimes, where we'll have these like random spikes in difficulty and content where the lesson last week was just full of stuff, and then the lesson this week is just not so full of stuff. Um, so it's a good thing though, because you're all going to handle this super well. We're just multiplying the whole time, so it's not going to be anything super new. It's just going to be some extra steps that maybe we're not so used to at this point. But those steps are things that we've also done a bunch of times. So I'm just going to move right into it. Um, yeah, if I seem a little weird, it's because I recorded this lesson and my microphone just decided to turn itself off on its laptop. And so I recorded this whole 30-minute lesson and it just had no audio. So I'm recovering from that. I feel okay now. I'm going to take a sip of coffee right now. Maybe that's not good. But you live and you learn. I think it's working right now. So we'll see how that goes. Um, but yeah, just know Bill Gates, if you're watching this, you're on my shit list. Um, and I'm coming for you. Anyways, so let's get into this, everyone. So 8.3 is all about multiplying binomials. And just as a refresher, I want to ask, what is a binomial? Who remembers what that is? In this case, a binomial is a polynomial that has two terms. So we're not working with one or three or whatever. We're working exclusively with binomials that have two terms in them. So if you think of a binomial, think of something that is like a duo or a pair of things. So when I'm thinking of iconic duos, I know I mentioned Phineas and Ferb in the other lesson I talked about binomials, but you could also have Bert and Ernie. Sesame Street is a legendary show. I watched that when I was a kid. They've got it going on. They're besties. They live together. I think they live together. I don't know. But they're iconic. They're great. Right now, as a video game, I'm playing Nier Automata right now, where you play these like anime characters with swords who are androids, and I'm like beating up a bunch of robots. It's a great time. So that's a very iconic pair to me at the moment. And also, no talk about iconic duos is complete without mentioning these legends, of course, Mr. Bacon and Mr. Jesperson. You can't go wrong. They're a dynamic duo, lovely boys, really appreciate them. So if you think of binomials, think of pairs or just sets of two, which they can be incredible ones like these. So I know what you might be thinking, Mr. Cecil, haven't we already been multiplying binomials? And to that I say yes and no. We're used to them, but we haven't been working with them the way we're going to do it today. So, as an example, we've done binomials like these, where I've got one term on the outside of some parentheses and then a binomial on the inside. That's what we did last week. So, we're used to binomials in that sense. But what we have not done is something like this, where in this case right here, I've got two binomials. I've got two terms on the outside of parentheses. So it's pretty much going to be a similar thing as what we did last week, but there's going to be maybe, two extra steps because there's a couple more things that we have to multiply, but it's all the same. None of it is really new stuff at all. It's just more in this case. So I want to talk about three methods for multiplying binomials, and none of them are the, single correct way. I'm just going to give you some options today for how to organize your thoughts a little bit. So, one method is the classic distributive property, which I didn't have a picture for distributive property. So, I just want to remind you all that our Lord and Saviors Megan Thee Stallion and Beyonce distributed the Savage remix to all streaming platforms and services to us last week. And just a reminder that it's an absolute banger and you should go listen to it. Another method is using a table, which I'll get into a little bit later, and the classic FOIL method as well, which I'll talk about after that. So 3 possible methods. I'm going to talk about all of them individually. So method 1 is classic distributive property. So we're going to frame it through this example here. So I want to simplify 2x plus 4 times 3x minus 7. So I'm taking one binomial and multiplying it by the other. So with distributive property, I'm going to think of this 3x minus 7 as just one whole thing that I'm going to distribute to start stuff off with. So I'm going to distribute all of 3x minus 7 to 2x plus 4. So it's going to look something like this. So I kind of split it into 2 different parts. So now I've got 2x times the whole thing, and then 4 times that whole thing. So I kind of just split it into 2 that way. And notice how they're separated by a plus sign because 2x and 4 were also separated by a plus sign. So it looks like a lot more work, but what I really like about this method is that it splits it up into parts that we are used to. We're used to doing the one term on the outside times the 2 terms on the inside of the parentheses. Now it's just 2 different problems that are both kind of paired together. So let's do them step by step. So I'm going to do this section first. I'm going to distribute that 2x to this part first. If it seems like I'm out of breath, it's because I recorded this lesson already and I am tired. I think that's the part that made me the most sad. I was like, I'm already talking so much and now I have to talk a bunch again. Man, what am I going to do when I actually have to go back and teach for real? It's going to be a work on my vocal cords again. Okay. So I'm going to distribute this 2x to the 3x minus 7. So again, these x's right here do not have exponents above them, right? So we always know that they have a 1 exponent if something's not written there. And if I'm multiplying these types of terms, we want to multiply the coefficients, the numbers, and our variables, and then put those 2 answers together. So 2 times 3 is going to give me 6. X to the 1 times x to the 1. We're going to add those exponents when we multiply them, so it'll be x to the 2. So for that first part, I'll have 6x to the second power. And then I have to do 2x times this negative 7. It's got a minus in front of it. And in this case, it doesn't have an x, so we're just going to multiply the coefficients and slap that extra x on there. So 2 times negative 7, I'm going to get negative 14, and then we'll put the x on there. So I should have minus 14x since it's negative. And then I'm going to bring down this second part right here because we have not done that yet. You can do both parts at the same time. I'm just doing them separately to show what all the steps are. So now let's do this second part next. So I'm going to distribute that 4 to the 3x minus 7. So I'm going to bring down my 2 other terms because we're already done with those. And then I'm going to do 4 times 3x. So we're going to multiply those coefficients. So 4 times 3 is going to give me 12. And only the 3 has an x, so we're going to slap that x on there. So I should have 12x plus 12x. And lastly, I have to do 4 times negative 7. Don't forget there's a minus in front of there. So it's going to give me negative 28. So you should have minus 28 at the end of your answer. It shouldn't be minus negative 28, just minus 28. It's that simple. Now, the one extra step that comes from doing these problems after we distribute is that I have got some like terms I've got to combine. Because if you really want to simplify something, you've got to combine all the stuff that goes together. And in this case, I have 2 terms that both have a single x. I can combine those. So I've got negative 14x because there's a minus in front of it, plus 12x. So really, you're just doing negative 14 plus 12. Which calculators are our best friends. You can always bust one of those babies out at any point. So negative 14 plus 12 is going to give me negative 2. So I'm going to have a negative 2x in the middle at the very end. I'm going to keep 6x to the second power and the minus 28. I'm just going to change what's in the middle. And that is how you do these problems. That's it. So you can set it up as distributed property like this way if you want to. You don't have to if it seems like some extra work. I'm just giving you some options. So our second option is using a table. And I really like this one because out of all the three methods, I think it's the best visual. I think it's a really good way to organize our terms because when you've got negatives going on, it can be kind of hard to tell, what's what, where does the plus sign go, where does the minus sign go? I know you guys give me that question a lot. So a table is really good for kind of parsing that out a little bit. So our problem is going to be x minus 3 times 4x minus 5, those two different binomials multiplying each other. So if you want to use a table, it's going to look something like this. So I've got one binomial on one side, that x and that negative 3 because there's a minus. They take up this column right here. And then I'm going to use my other binomial in this row above here, that 4x and negative 5 because there's a minus there. And where each little box meets, which each one, that's where our multiplication is going to go. So this box that's lining up with 4x and the x, that's where we're going to multiply those. So don't forget, there are no exponents above the x's, so we know there are ones there. And there's no number in front of this x, right? So I know a 1 has to be there as well. So I just got to multiply those. So I got to do my coefficients, 1 times 4, which gives me 4, and x to the 1 times x to the 1, which gives me x to the 2. So I should have 4x to the 2 for that value. And then we just have to do the other 3. So I have to do x to the 1 times negative 5, which I've just got a number and a variable. We know that those just slap together, right? So it should be negative 5x for that one. Excuse me. And then same thing for the row down here. So I'm going to do negative 3 times 4x. So I'm going to multiply my coefficients, negative 3 and 4. So I should have negative 12. And only this 4 has an x. So I'm just going to slap that x on. So I should have negative 12x. And the last corner, I have to multiply my two numbers, negative 3 and negative 5, which should give me positive 15. So the one thing that could be a problem with the table is how to organize your information afterwards. So your final answer should look like this, where I'm taking all 4 of my terms and just lining them up as normal. And so if you've got a negative number, that should be a minus sign. And if you've got a positive number, that should be a plus sign in this case. But don't forget, your last step should be combining like terms, which are usually going to be those middle ones because they both have an x. So I've got negative 5x minus 12x. So in a calculator, you'd want to do negative 5 minus 12, which should give you negative 17. So I'm going to keep that 4x to the second on the side, but then I'll have minus 17x in the middle, and then keep that plus 15. So that's really the only extra work you have to do. And then you're all done. So what I like about a table is that it's a really good visual. It separates everything out in a nice organized way. So for all my super organized people, for all of my Virgos in the audience, this could be a good one. It could be a little extra work in terms of drawing it, but it separates everything out and gives you a pretty good visual. So again, you don't have to use a table, but it's an option. And then last method is going to be our FOIL method. And I'm sure you've probably talked about it before, but just as a refresher, FOIL is an acronym. It separates the problem into 4 different parts. So first, outer, inner, and last. Get it? Because FOIL, FOIL. I know, great stuff. So let's use a problem as an example. So I want to simplify 5x minus 3 times 2x plus 1. So I'm going to separate those out into 4 parts. And that's where I'm going to bring my arrows in. So my first part, I'm going to do 5x times 2x, the first term of the first binomial times the first term in the second binomial. So that's my first part. I'm multiplying those two. Then I'm going to do 5x times the other term, in this case, the outer term of the second binomial. So I'm doing 5x times 1, and it's a positive one because it's got a plus in front of it. Then I do the same thing, but for the negative 3, and it's a negative because there's a minus in front of it. So I'm going to do negative 3 times 2x, which is the inner part, because it's the middle part. It's the inner part. So I'm going to multiply those two. And then my very last part, negative 3 times the last term, which is just 1. So I'm going to do all those 4 bits of multiplication, and I put a plus in between all of them, because you can't go wrong with a plus in this case. So let's do all that multiplication. So I have to do 5x times 2x, which again, those exponents are 1s because there's nothing there. So I'm going to multiply those coefficients, 5 times 2, which should give me 10, and then x to the 1 times x to the 1, which should give me x to the 2. So I should have 10x to the second power. My next one, 5x times 1, well, that's kind of nice because anything times 1 is just itself, right? So it should just be 5x. My next one, I'm doing negative 3 times 2x, so we should multiply our coefficients, our numbers. Negative 3 times 2, which gives me negative 6, and only the 2 has the x, so we're going to slap that x on there. I should have negative 6x. And then my last one, I'm doing negative 3 times 1, which again, anything times 1 is just itself, so it's going to be negative 3. So I've got all these lined up, all of my individual parts. So as a final answer, I just want to line them all up. And I replaced the pluses with a minus if they were a negative. So since this was negative 6x, instead of plus, I had minus 6x. And the same thing for the negative 3. But of course, we've got to do our last step. I have to combine those middle like terms because they both have an x. It's not quite simplified yet. So in this case, we're doing positive 5x minus 6x. So in a calculator, you should do positive 5 minus 6, which should give you negative 1. So in the middle, we should have negative 1x or just negative x in this case. And we're going to keep that 10x to the second power and that minus 3 on the ends. Oh, I've been talking a lot. Okay. That's what happens when you do a lesson a bunch of times in a row. Honestly, I think I just haven't been teaching a lot lately because it's like, okay, I did this literally every day for almost a year. I didn't get as tired as I am right now. I think it's just because I don't talk to anyone. So, I mean, I talk to people, but not out loud because I'm like at home, you know? Okay. I'm literally out of breath. This is so funny. Okay. So, that's how those are going to go down. So, let's try a couple others together just so we know what's up. I'm going to stick to the FOIL method because that's just what I'm most comfortable with. But if you want to do these using either a table or distributed property, go for it if you want to. But I'm going to stick with FOIL. If you want to pick another one, that's totally on you. Use what's most comfortable for you. So let's do this first one. X plus 3 times x plus 5. So I gotta do that first part. So x times x, and we know what's up with this one. I got a 1 exponent and a 1 exponent, so that should be x to the 2 right there. Then I gotta do x times my other term. So x times 5, again, I got a variable and I got a number, slap them together, so I got 5x. Same thing for my next part. I'm doing 3 times this x. So that should just give me 3x. And last bit, 3 times 5, just my numbers, I've got 15. And they're all pluses because I've got nothing but positives here. But of course, I've got to combine my like terms in the middle. So positive 5x plus 3x, I should have 8x in the middle. Keep my x to the 2, my plus 15 on the sides. So you'll have a nice easy one like that, maybe 2. Those aren't too bad. Let's try another one. So now I threw in a couple extra numbers. So again, my x's have got 1 exponents because there's no exponents written. So first step, I got to do 2x to the 1 times x to the 1. Now again, there's no number written in front of this x, so we know that's a 1 there as well, right? So our coefficients are going to be 2 times 1, which gives me 2. And x1 times x1 is going to be x to the 2. So I should have 2x to the second power for that one. Next step, I'm doing 2x times a positive 4. So 2 times 4 gives me 8. Only this term has an x, so we slap it on there. I've got 8x. Next step, that's a negative 5. Don't get that twisted. So I'm doing negative 5 times x or 1x. So it should be negative 5x or minus 5x in this case. And last step, I'm doing negative 5 times a positive 4. Calculators are our best friends. It should be negative 20, so you'll have minus 20 in your polynomial. But of course, last step, I gotta combine those like terms, so I'm gonna have 8x minus 5x in the middle, so it should just be 8 minus 5. You'll have 3x in the middle instead, but you'll keep those two terms on the outside as usual. Ooh, need water break already. How's everybody doing? Can't believe there's no one in the room and I managed to make that sound awkward. Okay. Two more. Let's do two more. So now I've got 2x minus 7 times 3x minus 4. And again, don't forget my x's have got no exponents, so they got 1s above them. So 2x minus 3x, well, we did that one already, right? 2 times 3 gives me 6. x1 times x1 gives me x to the 2, so I've got 6x to the 2. Next one, 2x times, that's a negative 4, dudes. So it's 2 times negative 4, which gives me negative 8. And only the 2 has an x, so it's minus 8x. Next step, that's a negative 7. So I'm doing negative 7 times 3x. So I should have negative 21x, or in this case, it'll be minus 21x in our polynomial. And last step, these are both negatives. So I've got negative 7 times negative 4, which is going to give us positive 28. Calculators are our BFFs. So I should have plus 28 in my polynomial. And then we got to combine our like terms, obviously, and they're both negatives. So I've got negative 8x minus 21. So in a calculator, negative 8 minus 21, I should have negative 29. So I'm going to keep those two terms on the outside, but I'm going to have negative 29x in the middle. Whew, I'm literally out of breath. I'm literally, Bill Gates, I'm coming for you. So hard for doing this to me. Okay, last one. I decided to be a jerk and include a trinomial just for some fun, just to go a little extra crazy, go stupid. So it's going to work the same way as a binomial did, but we're just going to have a little extra multiplying to do. Same rules apply. So I've got a single x by itself, so that's a 1 exponent. So let's do them in order. So I'm going to do my x times the first term of my polynomial over here. So x to the 1 times x to the 2. Don't forget we are adding those exponents, right? So I've got to do 1 plus 2. So I should have x to the third power for this one. Next step. Now I've got to do x times the next term. So I'm going to do x to the 1 times 7x. And there's no number in front of here, so we know that's a 1, right? So I'm doing 1 times 7, which gives me 7, and x to the 1 times x to the 1. So I should have x to the 2. We should have 7x to the 2 for that one. And I got to multiply this one by the third term. So I've got x to the 1 times, that's a negative 5. So negative 5 times 1 is negative 5. And this one is the only one with an x, so we're going to slap it on there. So I should have minus 5x for that one. Now we got to do it all again, but with the 2. So I've got 2 times x to the second power, which I got a number, I got a variable, slap them together. So I got plus 2x because they're both positive. Next step, 2 times 7x. I feel like we've done a lot of 2 times 7x today, which we know is 2 times 7, which is 14. This only has an x, so we slap it on there. So I should have plus 14x because they are both positive. And our last step, I got to do 2 times a negative 5, which should be negative 10. So at the end of our polynomial, we should have a minus 10. Now for this last step, I got to combine like terms, but if you've got a trinomial in here, I'm going to have 2 sets of stuff that I have to combine, 2 different pairs of like terms. So for this one, I've got 2 that both have an x to the second power, so we have to combine those. And looks like they're both positive, so 7x to the squared plus 2x squared should give me 9x squared. So that one's all set. And then I've also got a set where there's just a single x. One is -5, one is +14. So -5 plus 14 is also going to give me 9x. So we've got 9's here. So I added up my red pairs, add up my yellow pairs, and include those in the final answer. X to the third and -10, nothing else that goes with them, so they're just kind of chilling. They're single, they're ready to mingle. So, oh man, this bar is the bane of my existence here. Kind of like Bill Gates. I see you. So our final answer should be x to the third plus 9x squared after we combine the red pair, plus 9x after we combine the yellow pair, and then -10. So I might sneak in one where there's a trinomial, and you might have to do a little extra work on that one. So just be prepared for that. I know it says multiplying binomials, but like, there's no rules. There's a pandemic going on. I can do what I want, okay? That's how it goes. So that is all I wanted to do for today. If the audio on this doesn't work, I might have to riot. I might have to turn this into like a Molotov cocktail or something. We'll see what happens. But I miss you all so much. This sucks. But some good news. If you did not read my email, you should know that for some magical reason, I am not teaching Algebra 1 next year, which is a little disappointing because it was like, I made all this stuff for Algebra 1 and I can't use it for next year. That kind of sucks. But I'm teaching Algebra 2 next year, which is kind of cool because when I was student teaching, I taught Algebra 2. So it's kind of a fun throwback. But what's exciting about that is that, if I'm still teaching it in 2 years, there's a really good possibility that I'm going to have some of you all again in my classroom. And that just like makes me super excited and happy. I know for some of you, maybe you're like, oh God, like, don't put me with this moron again. But it just makes me happy that I might get to have you all in the future when you're changing and maturing. And I'm just excited to see all the growth that you have. And maybe I might have some of you next year for all of you insane crazies who are doubling up on geometry and algebra 2. So I could have some of you as soon as next year, but I might have a lot of you in 2 years. So I'm super excited about that. If you're trying to be in my class again, talk to your counselor, I guess. And if you don't want to be in my class again, talk to your counselor. But I'm going to sign off on that. I hope you all enjoy the rest of your week. It's Friday that I'm recording this, so hopefully you don't have any work on the weekend, as long as you didn't hold it off. So that's all I'm going to have for today. So fingers crossed the mic works. Bye, everyone.